allow the host to record. Okay. I think it's now recording, so we can start our business. We go to our big blue button. Okay. I would say you are welcome to this makeup class. As we agreed some time back, that is supposed to be last week, we are supposed to look at our lecture A5, just some sort of like a summary of what happened. That is lecture A5 and lecture A6. Then from there, we'll go through some problems and how to solve those problems to prepare you guys for the quiz that will be open tomorrow at 00:00 up to about midnight. That's when it will be closing. So you have like 24 hours of you guys attempting those problems. When I talk about 24 hours, it does not mean that you are going to have the 24 hours doing your calculations. No, once you start attempting your quiz, you will only be given 45 minutes. And after 45 minutes, you need to submit. Apart from that, you will also be given another opportunity. You have like 2 attempts. Each 45 minutes. Okay. So for lecture A5, if you can remember, we looked at equilibrium of rigid bodies that was in 2 dimensions and in 3 dimensions. Hope you can remember. Apart from that, we looked at free body diagrams, how to draw the free body diagrams. There were those, I don't know if there are 4 or 5 steps for you to come out with the correct, or for you to draw the correct free body diagram. The first step was you first need to decide which system to isolate. You make sure that that system that you are isolating makes sense. Of course, when you isolate one, you need to include at least unknown forces and known forces. If you isolate a system which has known forces, it does not make sense. Then what are you looking for? So you need to isolate a system which will have reactions, support joints, unknown and known forces. Once you do that, you got the next step, which is very, very crucial. That is now drawing the so-called free body diagram, showing the external boundaries. We forget about the internal forces. We are only going to look at the external boundaries. We also need to show some supports which are along the external boundary. The third step is you identify all forces which act on your system that you have isolated. You need to represent all forces using the arrows, or you represent them as vectors showing the magnitude, the direction, and the sense, the direction. For unknown forces, you need to assume the sense, and you need to be consistent. Yes?
Sorry for interrupting, but are you sharing anything on your screen?
I've only, I think there's only a whiteboard.
Oh, okay.
Yeah. You want me to start drawing something?
No. People are concerned. Like they can't see anything. They thought you were sharing.
But you can get me?
Yes.
Yes, I'm just trying to remind you of what we discussed in lecture A5.
Okay.
Yeah, so what I'm just showing you is just a whiteboard. Okay. So I was saying the third step, if you assume the sign, you need to be consistent. What I meant is, if I say that is positive and that is positive, you need to be consistent. As you are doing your calculations, you need to know that this is Raymond Mulenga. Raymond Mulenga, kindly mute your mic. So if it is a moment, you agree that that is positive. So anything opposite to that, it will be negative. That is, of course, clockwise will be negative, facing down will be negative, and facing left would be negative. You need to be consistent. The fourth step is you indicate the coordinate system. This is very, very much important. The coordinate system where you say that is your y, then that is your x. This is very, very much important. Once you do that, you are done with drawing your free body diagram. And note that it is not necessary for you to put unnecessary stuff on your free body diagram. At the end, it might confuse you. Just add what is necessary: the force, the unknown force, the directions, the sense, the dimensions, and so on. Don't put any unnecessary stuff. Apart from that, we also mentioned on our equations of equilibrium, which is the summation of forces in the y, summation of forces in the y, summation of forces in the z to be equals to 0. We also mentioned about the summation of moments about a point, or summation of moments about x-axis, summation of moments about y-axis, summation of moments about z-axis should be equals to 0. You can as well remember about how to calculate where you have a body, then of course you have a couple moment, and you have a number of forces. How to calculate the resultant moment about that body. Can you remember where we say summation of moments about that point? For now, we can call it maybe O would be equals to the cross product and the force itself, then plus the moment. If you can remember, I said this moment is a sliding vector, meaning you can move it without changing anything. Apart from that, we mentioned about realization, the modeling itself. How do we model a force, or how do we model a system looking at its supports? We mentioned about a roller, we mentioned about a rocker, we mentioned about a surface where there is no friction. How do we model the reactions? For a roller, if I can remember very well, you model a force that is supposed to be perpendicular. That is for a roller, a rocker, or any surface that is that has got no friction. We also mentioned about a pin connection. A pin connection, it needs two reaction forces. The other one, if we say that is our X and Y, if that is our Y, and that is our X, this of course it will be the force in the Y, and the other one will be the force in the X. I can remember I told you something concerning a pin connection. If the pin connection, the member itself, it is free to rotate, or if it is not free to rotate. If it is free to rotate, the only reaction that you are going to have is one force, that is the Fx, and the other one, the Fy. But if that member, it is being restrained from rotating, then you also need a moment to restrain the translation, the rotation. We also mentioned about a fixed support. A fixed support, it's more like a pin connection without the member itself rotating. You model it having the force in the X, the force in the Y, and the moment. This moment, it is preventing the member to rotate. We mentioned about equilibrium in 2D and in 3D. Ernest Nkata, you are making noise. What's your problem? We also looked at 3D. It's also the same principle. A smooth surface or ball-supported reaction will be just one force, which is also the same as a roller, a rocker. When it comes to a roller or wheel support with lateral constraint, do you know what that means? Lateral constraint. This is in 3D. You have your X, Y, if this is going to be my Z. If this will be my Z. Lateral constraint, it simply means the member can move in the X, Y, or Z. So it has got a lateral constraint, which simply means one of the axes, Z, X, or Y, it cannot move. So this is also the same as a pin connection, where you have that, you have, depending if the lateral constraint is in the X, then you have a component in the y and a component in the z, which is also the same as a pin reaction or a pin support. Where you have a ball and socket joint, you need 3 support reactions, that is in the x, in the y, and in the z. A fixed connection, this is going to have a component in the x, a component in the y, a component in the z. Apart from that, it will also going to have a moment in the z, a moment in the x, and a moment in the y. That is a fixed connection in 3D. A fixed connection in 3D, you have the 3 components, the reactions x, y, and z, and also the moments. Moment in the z, moment in the x, moment in the y. So already you know that for a fixed support, you will have 6 equations: summation of moments in the x, summation of moments in the y, summation of moments in the z. Apart from that, summation of forces in the x, summation of forces in the y, summation of forces in z. So if you have got a fixed connection in 3D, you have 6 equations. If you have 6 unknowns, you are supposed to be able to calculate or to determine those unknown forces. Note that when we are looking at moments in the x, moments in the y, moments in the z, any force that is parallel, as an example, the one that is parallel to z-axis, or the force that passes through the z-axis, is going to give you 0 moment. So you don't consider those. So any force that is parallel, or the one that is passing through that axis, does not bring about a moment. Take note of that. Take note of that. So let me give you, if someone would want to reason, or someone maybe got what I mentioned. If I've got a force parallel to the y-axis, or the force is passing through the y-axis, if I want to calculate the moment about the z-axis, is that force that is passing through the y-axis going to create a moment or not?
No.
I'm not getting.
No.
I'll call you. I'm in class. I'm in class. I'll call you. The what? Hello? There's someone who wants to attempt?
Would you kindly repeat the question?
I was saying, if I've got a force that is passing through the y-axis, the way I've drawn it there, the y-axis, determine the moment about the z-axis. Then my question was, using that force that passes along the y-axis, are you going to get a moment about that force? That was my question. Hello?
No, sir, no.
Someone has said no. Correct. So any force that is parallel or perpendicular to that specific axis, you don't consider a moment because it doesn't bring about a moment. Take note of that. Unless there's something that I forgot, but those are things that we discussed in lecture A5. So when we go to lecture A6, we are looking at structural analysis, which is defined as the design of the performance of a given structure under prescribed loads and other external effects, such as the movement and the temperature change. And I mentioned that we won't look at any thermal stresses. Thermal stresses, you look at them in the second component, the second part, which is the strength of materials. Lecture A5 was looking at internal forces. Since the other lectures, starting from 1 up to 4, we are looking at external forces. But now lecture A6 is now looking at the internal forces. Meaning you need to apply the knowledge that you have already obtained from the previous lectures, that is lecture 1 up to lecture A5. So the first thing that you need to do, if you have been given a body, as an example, you have been given a truss, then of course it is being supported. It is being supported by maybe say a pin. I know the first thing that I need to do, if it's a pin, I need to model my reactions, and which says if it's a pin, I need two, the one horizontal, the one vertical, which is the F in the Y and the F in the X. Then, of course, I can have another force there. Then here, if it's a roller or if it's a fixed connection, in 2D, I'll have a component in the Y, the component in the X. And apart from that, I'm also going to have a moment if it's a fixed connection. And of course, we will have members, internal members in that truss. Something like that. So the first thing that you need to do, you first determine the external, which happens to be this and that. Then when you are done, that's when you come to determine now the internal forces. And I also mentioned that the problems that you have, they are only going to be statically determinant. These are forces where you will have the equal, or rather the number of unknowns is supposed to be equal to the number of the basic equations of equilibrium. That's what I mentioned. the problems in this lecture, you need to understand the procedure of drawing a correct free body diagram, which was lecture A5 and lecture A2. And I also mentioned that a truss is a two-force member. Two-force member, meaning if this is the member AB, if that is A and that is B, that is if this is A and that is B. This is a two-force member, meaning they are only a force parallel to its axis. So it's a two-force member. Same magnitude, but in opposite direction. This is the third law coming from Sir Newton. And we also made an assumption that the loads are only applied on joints. So we would find a load on the joint, not anywhere else. That's what I mentioned. Not anywhere else. This one, no. And we also assumed that the members are connected only using frictionless pins. That's the reason why they are two force members. And I said there are two methods of solving these problems. One method of sections, the other one method of joints. Then in lecture A6, we looked at the methods of joints, which only applies two equations, which is summation of forces in the X and summation of forces in the Y should be equal to 0. Method of joints, there are only two equations that you need to apply. Summation of forces in the Y and summation of forces in the Y-axis is supposed to be equal to 0. When analyzing these problems using the method of joints, always start at a joint with at least one known force and the maximum of two unknown forces. Don't forget that. A joint where you have at least one known force and the maximum of two unknown forces. The logic is there. Why am I saying the logic is there? For this method, there are only two equations, which is summation of forces in the X and summation of forces in the Y. So if you get a joint where there are more than two unknowns, you get stuck because you only have two equations of equilibrium that are applicable, which is summation of forces in the X and summation of forces in the Y. So when you have been instructed, when you have been told to solve this problem using the method of joints, look for a joint which has got at least one known force, and the maximum of two unknown forces. Then I also mentioned of if the force is unknown, how are you going to know the direction? Is it going to be going left, right, up, down? Is it going to be C or T? When I talk about C, can you remember I mentioned about compressive force? So what I had drawn here, this is showing me this is T, that is tension. But if it was opposite, like that, and the other force, like that, it is going to be compressive force, which is C. So there are two methods of doing that. The first one was by inspection and by assumption. Inspection is where you have some experience. Now, when you look at the truss, you would know that this force automatically, it will be in tension, it will be in compression, or it will be facing left, right, up, or down. If you don't have that experience, you are going to use the method of assumption, where you would say this force will be in tension, this force will be in compression. After you do your calculations, at the end, you find your answer to be negative. That is indicating that your assumption is wrong. It doesn't mean your calculations are wrong. No, your assumption in terms of the sense, it is wrong. So you need to reverse. Since you know it is negative, you had assumed that it is in tension. You need to reverse. It is not in tension, it is now in compression. So when you go to the next joint, reverse the assumption that you had made on the joint A. So if at joint A you had assumed it is in tension, you find your answer is negative. When you go to joint B, you need to apply the correct sense. I hope that is clear. Then lastly, I also mentioned about a zero force member. What is a zero force member? Can you remember about that? I mentioned about a zero force member. A zero force member are normally used for the purpose of stability, to make the truss to have stability, more especially during construction and sometimes when the load system changes. The zero force member can be known just by inspection. Don't assume that this is a zero force member. No, you only inspect whether this member is a zero force member or not any other assumption. No, it is by inspection. I can give an example, basic example in understanding. If you have a force system and another force, where I know that this is supposed to be the Y and that is supposed to be the X. I have a force, this is F. I can call it F1, then I can call this F2. And all of us, we know that there's a 90 degrees here in between these two forces. Just by inspection, you can know that F1 and F2 are both zero force members. Why am I saying so? When I apply my basic equations of equilibrium, where I'm going to say summation of forces in the X, summation of forces in the X should be equal to 0. And you do the same summation of forces in the Y would be equals to 0. Automatically, your F2 it has got only one component in the y. Meanwhile, your F1 has got only one component in the x. So F1 and F2, they are zero force members. If I extend, then I say there's another force there. Of course, that will be F3. That is F1. And that is F2. When I have another force, F3, you would realize that F2 and F3, they are no longer zero force members. Why? Because if I apply the summation of forces in the y, you are going to find two opposite forces, that is F2 and F3, indicating that they cannot be equal to zero. But F1 still remains a zero force member. F1 still remains a zero force member. If I add another force, that will be F4. And of course, I give you the angle, theta, maybe is equals to 30 degrees. F1 is no longer a zero force member. Why? Because F1 is going to have a component that will come from the force F4. So even just from inspection, the way I've drawn the F4, if F1 is facing the right, then my F4 is supposed to be facing opposite direction, not like that. This is the third law coming from our Sir Newton's. The force is always supposed to be equal but opposite. Unless there is a question, we move to our problems. Ernest Carter is saying that he can't get anything, he can't hear anything. Work on your settings. Kenna says she can't get me. Work on your settings. Christopher was asking, so if we have a force between F2 and F3, F1 is no longer a zero force member. I've explained that, Christopher. Raymond Mlenga noted. Okay. So there are no questions. We move to our, we just try to attempt one or two. Oh, no. Sorry for that. Sorry for that. It's just something that I want to check if it will work. I want to see if this can work. Can you confirm that you can see the PDF document force vectors in 3D?
Yes, sir.
Which platform are you using?
Google Meet.
Which platform are you using? Google Meet.
Google Meet, sir.
Or...
Google Meet.
Okay, someone using Big Blue button, can you confirm if you can see what I've shared on the screen? That is a force vectors in 3D, a PDF document.
Yes.
You are viewing using Big Blue button, right?
Yes, sir.
Okay. So today I will try to help you guys. We go through these our examples or our problems. Example 2-6. Two forces act on the hook shown in the figure. Specify the magnitude of F2 and its coordinate direction angles so that the resultant force FR acts along the positive y-axis and has a magnitude of 800 Newton. First thing first, what do we have? What do we have? You have been given the 800 Newton, and you have been told that our resultant force FR is going to act in the positive y-axis. So automatically I know the component in the x is automatically 0. When you look at the drawing itself, it is showing you have been given the position, we have been given the direction angles. That is alpha 45 degrees, 60 degrees, and 120 degrees. That is alpha, beta, and gamma, respectively. The first thing, what do we do? This was a quiz. This was a quiz. People failed to calculate that. Once you have been given the angles, which equation are you supposed to use so that you can get the force? Or how do you get the direction angles? Cos alpha is equals to the force, which is the F1, over the magnitude of F1. We have already been given the force. Sorry, we have already been given the angle. We have been given alpha, beta, and gamma. You have been told that the magnitude is passing along the positive y-axis. This is a parallelogram. We know F1, we don't know F2, but we know FR, and we know the direction angles of F F1. Can someone tell me the next step, or which equation to use from this step? We need to be active. Students are here to learn. So no one will laugh at you. Just try to, your reasoning. What is the next step? This is what you have been given. What is the next step?
Sir,
Yes.
after looking at the other, now we are going to find the F2. Then can we separate that the rectangle into like two triangles, where we have the F2, then of course we have our F1 which is given. Then the other one, because here is the other one here will be the same as F1.
You are saying we separate?
Yes, we try to separate them into two triangles.
Now, if you separate them, you tell me which equations are you going to use? Which equations are you going to use?
Sir.
You are right, yes, but now which equations are you going to use when you separate those triangles?
We try to use the sine and the cosine.
You use the sine and the cosine rule. The cosine and the sine rule can work, but how are you going to get the angles? The angle between F1. How are you going to get the angles between F1 and FR? Take note that this is in 3D. This is not in 2D. How are you going to get the angle between F1 and FR? Hello? Yes, yes. Go ahead. Your line is cutting. Your line is cutting. We can't get you. Your line is cutting. I can't get you.
Sir.
Yes.
I think, sir, we resolve that F1 into X, Y, and Z components by using the formula F for that one, saying cos alpha is equal to Fx, so can find since we have alpha and we have the vector. We can also find the y component using the same formula, saying cos beta equal to fy over fx. So we can find the fy from there. Just like cos gamma, we can find again the z component from there. So now we are going to add the components of f1 And the F2 will be just in terms of, since we are not given the magnitudes. So we are going to say F2xi, F2xy, and force, which has only the component along the y-axis, which is 800J. So we can find Fyx, F2y, F2x, and F2z from there. And its magnitude using the formula.
Okay.
Sure, I'm done.
Okay. This is how simple it is. The first thing, we need, since we have been given the alpha, beta, and gamma, and we already know our F1, right? The first thing that we do, we need to represent our force in Cartesian notation. All of us, we know that the resultant FR is equals to F1 plus F2. We first make all the forces to be in Cartesian notation. You have your F1 in Cartesian notation. You do the same for your F2. This is how it looks like in Cartesian notation. The component in the X, the component in the Y, the component in the Z. Like just what our colleague was trying to explain, putting the components in the X, Y, and Z. Then we know that we have already been given the FR as 800, and it is, the question says the resultant force acts along the positive y-axis, which is that, meaning the component in the X, the component in the Z, they are zero. This is what this means. This is what this means. The component in the X, the component in the Z, they are zeros. You only have that. We use our equation now. FR is equals to F1 plus F2. We know FR and we know F1. We don't know F2. This is how you get your F2. Very simple. How do you get this? How do you calculate this? Don't forget, we will be adding or subtracting the respective unity vectors. We are going to subtract 0I minus 212.1I. I got the next one, 800J minus plus 150J. 0K minus 150K. This is how you get your F2. Now, all of us, we know how to get the magnitude. The magnitude is the square root of these components, the 212, the 650, and the 150, which will be 700 Newton. How do I get the coordinate direction angles? We know cos alpha is equals to the force in the X component over its magnitude. You do the same for beta, you do the same for gamma. If you want to get the angle, all of us, we know this is just elementary mathematics. Inverse cos of 212 over 700, then you would find the angle in degrees. Example 3-1. An elastic rubber band is attached to points A and B as shown. Determine its length and direction measured from A towards B. Someone to help us on what to do?
So,
Yes. Let's go ahead.
You click the coordinates.
Yes, we get coordinates.
Get the coordinates for A. And then also get coordinates for B. Then we find the position vector R.
How do we get the position vector R?
By subtracting where we're going, where the position where we're going to -1 or 4, which is A minus B. When you put them in Cartesian form.
A minus B, not B minus A.
Oh, B minus A. I'm sorry, sir. B minus A. Sorry.
Okay.
Yeah. Then after that, we define the unit vector.
How do we get the unit vector?
We divide each component of the result of the position vector by the resultant.
How do we get the resultant?
The resultant, we square each component, then we square root them.
Are you talking about the resultant or you're talking about the magnitude?
Oh, I'm talking about the magnitude.
sorry, the slide doesn't change. There's still yes, there's still the previous question.
Which platform are you using?
Big blue button.
Then these guys who are using Google Meet, can you see the question?
Yes, sir, we can see the question.
Okay, so is there something wrong with big blue button? Okay, let me just try to stop sharing.
No, I think it's okay.
No, someone can't see.
So it's okay, we're able to see.
But someone says he can't see.
You have to refresh the screen. Big blue button.
Those using big blue button, can you see the question now?
Back to the one that time when we were talking, we were able to see. Now it has gone back to the previous. I think it's loading.
Those using Google Meet, can you see the question?
No, we can't see the question, sir.
Are you sure you can't see the question?
No.
There is nothing, so I can't say anything.
You can see the question now, those using Google Meet.
No, sir. Okay, we can see it right now. We are able to see
You
it,
can
sir.
see it. Eh?
Yes, sir.
Now, those using big blue button, can you see the question?
No, sir, we are seeing question number, the previous question we are doing, not the current one. Example 26.
And what's wrong with this? Okay, let me see what I can do. Let me go to big blue button. Close that. Share the screen. Share the window. PDF. I'm sure you are now able to see the question. Those using big blue button.
Yes, this is example 3.1.
Okay. So the other gentleman was just explaining how everything. Though he was, I don't know, he was scared. He was mentioning about the resultant. I don't know where the resultant is coming from. Measured from A to B. What they mean when they say the length, they mean the magnitude. So the first thing, you get the coordinates at A, coordinates at B. Subtract your B, I, J, and K minus those at A. Once you do that, you determine the magnitude, which is the square root of those components. Then how do we get the direction angles? The direction angles is always the force over the magnitude. The force in the component, in the x component over the magnitude, the force in the y component over the magnitude, and the force in the z direction over the magnitude. That's how simple it is. So the first thing, you get your coordinates. After getting your coordinates, you get your position vector. After you get your position vector, you get your R, you get your magnitude. That is the length that you are looking for, which is the 7 meters. After that, how do you get your coordinate direction angles, which is you do the same for the gamma and beta. Another question. Determine the length of wires AD, BD, and C and B. Someone to try to attempt Someone to attempt? Someone to help?
I think maybe you first of all find the coordinate, the position vectors of each. Then after we're done with that one, I need to start between 2 points. And then over they're saying these between which one and which one?
You are finding the distance AD, DB, and the CD.
I wanted that one for where he's talking about D. At D is the midpoint.
Yeah, D is a middle point.
Okay, after we are done with that one, like we take the D is the midpoint of
Okay. So what are the coordinates of C? What are the coordinates of C?
0,0,2.
Someone is saying 0, 0,
2.
correct. What are the coordinates of A?
2,0,1.5.
Coordinates of A.
2,0,1.5.
You are saying 0?
No, sir. I'm saying 2,0,1.5.
Positive 2,
Positive
0,
1.5.
The coordinates for B.
B is 0, 2, 0.5.
Very simple. Very simple. So then the question it's saying D is the middle point of AB. For the sake of time, you can just calculate the magnitude of AB and then divide by 2, which will simply mean you have the distance AD and BD. So the coordinates at D is just a matter of 1-1-1. You count your RA AD, you subtract those at D minus those at A. You do the same for RBD. You subtract those at D minus those at B. You do the same for RCD. Then at the end, you find your magnitude, RAD, your RBD, and your RCD. That's how simple it is. Another example. Express F, B, and F, C in Cartesian vector form. Maybe is 450 Newton. Someone to attempt, someone to help, how, give us the stages on solving that problem. Yes, go ahead.
So you define first, you get the coordinates of A, and of B, and of C.
Okay.
Then you find where the force FB lies.
You have said you get the coordinates A, B, and C. Then the next thing.
Yeah. You find then you in
Yes.
then after doing so, you find the unit vector.
You have said you find the distance AB. How do you find the distance AB?
Yes, sir.
How do you find the position vector R?
Oh, okay. You get the coordinates of A and B. You subtract the then you put them into Cartesian form, which is the position vectors of A and B. Then you subtract B minus A.
Okay. Then after that, what is the next stage?
Then after that, you find the unit vector.
How do you find the unit vector?
You divide all the Cartesian components with by the magnitude of the
But so far you have not told me how to calculate the magnitude. How are you going to divide the magnitude when you have not yet calculated it?
Oh, okay. Let's see. Okay. So you find the magnitude by squaring all the components and adding them. Then you find the square root.
Okay.
Yes, sir.
Then from there.
Then from there you divide them. You divide the magnitude in all the components, so that you find the unit vector.
Okay.
Right.
Correct. This is how simple it is. The first thing you get your position attractive. You start from B minus those at A. Once you do that, the next thing is now you calculate the magnitude. How do you calculate the magnitude? The magnitude is a square root. In this case, it will be a square root of 2 squared plus 1 squared plus 2 squared. You are going to find your RB to be equals to 3. Once you do that, you get your unit vector now. It's supposed to be over the magnitude of RC. Once you have that in Cartesian notation form, you multiply this unit vector times the respective force 100. Meaning you multiply the 600 times the unit vector moving from A to B. You also multiply the 450 times the unit vector from A to C. Your final answer would be negative 400I minus 200J plus 400K. And FC would be minus 200I plus 200J plus 350K. They are all in newtons. Your quiz, tomorrow you'll be asked to find these forces. You are going to have multiple choice questions and you are going to have numerical questions where you need to type. As an example, the FB, it is saying FB is equals to negative 400I minus 200J plus 400K. Here, the instructions are there. The way you type, if your answer is like that one, being as calculated to be that FB, you negative, no space 400, no space I, no space minus, no space 200, no space J, no space K. The Newton, don't type the Newton where you are putting your answer. You are going to have select which units you are using. Take note of that. No space. Is asking you, give me the coordinates of point B. The way you give me the coordinates, if it says bracket, open bracket, no space. If it comma, no space. If it, again, it's like, yes? Yes. Go ahead. Someone wants to ask something.
Yes, so for me, I think I'm having network problems. Will we share the same notes on Moodle, like the same PDF?
I can share. There's no problem. I've already shared on Moodle. I've already shared. Those who are using big blue button, you have that. You can even download it. Even you guys who are using Google Meet, check on the there's an attachment there. What?
Yeah.
Yes.
You say that we don't have to, so we just say if we're supposed to put the answer, it's just into the Cartesian component. So we just put negative 400, then we put J without space, we put negative 200 J plus without space 400 J.
Yes, no space.
Sorry?
No space.
No putting brackets.
Look at the instructions. The instruction, it is showing you the example. As an example, if there are brackets, put brackets. If there are no brackets, don't put brackets. Read the instructions.
Yes, the audio is breaking up.
It's breaking. Can barely get you.
Hello?
No, sir, you're still breaking, sir.
Maybe there's something wrong with the internet. Hello? Hello?
Sir, excuse me, sir.
Yes.
I want to find out about thing like last time when you give us that quiz which you wrote last time, there was a certain diagram which was in the second quadrant, which is of which the component was supposed to be a negative, but it was a multiple choice question. The answers that were there for that thing was partly a positive, and of which some of us were only
I think I told your class rep aware of that. It was an error when I was typing. I forgot to put a negative. So what that simply means, those who have been affected, they will be considered. That's what I mentioned. Except I don't just have time. Once I have time, I'll go through. I have a list of those who think they were affected. Hope I've answered your problem or maybe your concern.
You mean somebody submitted it?
What?
I'm asking that you mean somebody submitted the list of those that are aware of it?
Someone submitted what?
Those people that were affected.
Yes, I told the class rep to tell all those who think they were affected to tell them what was the problem, which question, which quiz, and the class rep forwarded those names of those guys who say they were affected. So I'll find time and I'll work on that. And justice will be done.
Sir,
Yes.
when you're explaining about how to write how to insert the
Yes, I was saying, follow the instructions. If it says brackets, if it says no space, no space. Don't put the unit together with the answer. There is a box next where you're going to type your answer, your figures. The next box, that's where you're going to select your unit, the units that you have used. I was emphasizing.
Okay, sir. Thank you very much.
Okay. The frame in these figures subjected to a horizontal force F of 490 Newton. Yes.
Which lecture notes will the quiz be based on again?
Lecture 3. These problems they are in lecture 3.
Okay.
Yep. Determine the magnitude of the components of this force parallel and perpendicular to member AB. The question here is saying determine the magnitude of the components of the force parallel AB and perpendicular to AB. This is where we use our dot product. Can you remember about our dot product? A dot product, it is used to calculate the angles between two force components or forces that specific member. So this question is just asking you if you understand when, where, and how to apply the dot product. We have been given the F, it is 400 Newton in Cartesian notation. So this simply means the component in the X and the component in the Z, they are zeros. In other words, it is F is equals to 0I plus 490J plus 0K in newtons. This is what they are asking for. You want a force which is perpendicular to AB and the force which is parallel to AB. So this is the force we are talking about, the FAB, and the force which is perpendicular to the force AB. All of us, we know when to use the cos and when to use the sine. So in short, the component, the perpendicular component, you get it by multiplying the force itself times the sine theta. The parallel component this is how simple it is. Right? But always, the first thing that we do, we represent our force as a unit vector, which is normally represented by that. We have our 2, we have our 6, we have our 3. The first thing, get coordinates at A, get coordinates at B. Right? That's where those numbers, that's where they're coming from. How to get your magnitude is the square root of a 2 squared plus 6 squared plus 6 squared, you're going to get a 7. A dot product, all of us, we know that a force FAB is the same as the vector times the cos theta. Theta, that is the angle between those two forces that we are talking about. Which is also the same as the force dot the unit vector. We already have the unit vector, which is a 2I plus U. That here Our F, there is 0I plus 490J plus 0K. What does it mean? It means 0 times 2I plus 490 times 6J plus 0 times 3K. I'm sure all of us, we know any number multiplied times 0 is equals to 0. So we are going to remain with 490J times 6 over 7. R gives you what? It doesn't give you a vector. You're going to find your answer to be 420 Newton. Now, how do I get the direction? We know how to get the direction. We know that FAB is the same as FAB.UB, which is that. Once you get that, there's something that is missing here. There's something that is missing. Here it is supposed to be the angle perpendicular. So the angle perpendicular, you can use this method or theta. So the first thing that you need to do is to calculate the angle. Once you get the angle, we already need theta. Or you can use this method to find the magnitude of that force. At the end of this, you get the magnitude of this, that, and that. This is supposed to be the last example. The pipe shown is subjected to a force 80 Newton. Determine the angle theta between F and the pipe segment BA and the projection of F along this same line. This question is also talking about the application or product to find the angles between two forces, and also we use the same dot product to find the projection and the angles and the forces that are parallel or perpendicular to a given force. We use the same principles. We get coordinates. Once we get coordinates, what do we do? Position. Sorry for that. This is the same principle get the position vector, get the unit vector. There are two ways of solving this problem. You can get coordinates about the center or OR. You still get the same answer or same solution. Unless there's any question. Unless if there's a question. Yes, I've seen there's the Mute wants to ask something. Mute wants to ask something. Hello, Mute wants to say something. Okay, it looks like there are no questions. I would say all the best with your quiz and see you on Friday for our lecture.
There's a sample of an introduction. Just confirm if that's the way we should be doing it.
I can't get you.
I'm saying there's a sample of how you say you should enter with the digits. So I've tried to do it and just approve it. That's the way we should be doing it.
This is what, Munalula?
Yes, sir.
Yes, something like that, no space. And the unit, there is a specific box where you select which unit. For the unit, you don't type.
Okay.
If the solution, the example that I've given you, it is saying use this type of brackets, leave it the way it is. If there are no brackets, it would just be 200 J without space minus another 200 J. This is supposed to be I, J, then maybe plus another 200 K. If there are no brackets, you present it the way I've just presented. I've shared something there. If it says give your answer with 2 decimal places, if your answer, an example, is 45 Newton, if your answer is 45 Newton, you round off. If you have got 21, it will be something like that. That is what you type. The unit itself, it will come in a separate box where you don't type, you just select. I hope that is clear.
I appreciate it.
Yes?
Is there a way of maybe a way of we can try to get the PDF of the question that they are
I can't get you. Who am I talking to? This is the...
Pardon?
Who am I talking to? Your name? Hello?
Yes, sir. I was saying that a way in which I can get a video for these questions that we have from Monday.
Can you see your screen? You can see there is something on the screen, right? You can see something on your screen.
Yes.
Those using big blue button on the screen, on your far bottom left, you are going to see there's an arrow there. Have you seen the arrow? Those using big blue button, have you seen the arrow on your far left? There is an arrow there. On your right is written scanned with the that's a scanner. But on your left, there's an arrow. If you can see that arrow, just click on that arrow. You'll be able to download that. Just click that arrow. You'll be able to download. You have seen it? Those using Google Meet, check. There is a link, there is an attachment. Just click on the attachment, you'll be able to download those solutions. Okay, my time is 16 hours. I end here. See you on Friday, where we'll look at lecture looking at structure analysis. Those are trusses, but we will only look at the methods of sections. Of course, we'll look at in 2 dimensions and 3D trusses. All the best.
Okay.